Welcome. This is a short tutorial about classes and objects in Python. Object-oriented programming is very important in general for programming. It's not so important at the beginning when you start scripting for your course or for science. What you know so far is how to write and use functions. And when you do some analysis, then you call one function after the other, or you might even call it in loops and get some output. Object-oriented programming is a bit different. Imagine you have a football match and you have 22 players, and all of them would be quite similar and they would have a certain state. So rather than defining all 22 players with functions or on their own, it would be quite good to have something that is an object called player, and then you can assign the different states to 22 different instances of that type player. So it's a bit like you define your own variable type, a more complex variable type, and then you can have several instances of this class. And classes have their own variables, and they have also functions. An example that we have, we will have a very basic robot, and this robot will have two variables for its position, one for the x coordinate and one for the y coordinate, and it will have some functions to move it around and to print where it is at the moment. And once I've defined what my object of a robot should look like, having these two coordinates and being able to move, I can just create as many instances of that robot as I want, and then I can move it around. So the very basic idea of object-oriented programming and of classes is that when you have something that has a state, then it's good to represent it as an object. So let's simply define our own very simple class, which I do here. So I define a class and I call it class robot. And I say first, this class shall have a function that I call move. And move shall have three parameters: self, delta x, and delta y. So self is a special variable. Whenever it is within a class, then self refers to the current state of that class. So self holds all the variables of that instance of that class. In our example, we have a self.x and a self.y. Those two variables define my present position of the robot. And when I move the robot, I want to change self.x by the delta x. And I want to change self.y by the delta y. So when I call move, then I change self.x and self.y by delta x and delta y. So whenever I have a function within a class that uses the present state, that uses self, then I pass self as the very first parameter, and then I pass the other parameters. And then I define another second function for this class, which I call print position, and I only pass that self, and it just shall print self.x and self.y. So to see how using classes behaves in practice, we use these 5 lines of code. So first I create a variable called Alice, and Alice is a robot. And to create an instance of a class, I use the class name followed by those brackets. So this creates an instance of that class called Alice. So Alice needs to have an x and a y so that I can move it around, because x and y are not defined at the moment. The initial state is not defined. And that's what I do in these next 2 lines. I say at first it's Alice.x equals 5 and then Alice.y equals 5. So more exciting part here, ls.move. So I call the function that ls has. This function is called move. And I pass two parameters. So I pass a 2 and a 3. So I don't pass the self. So the self is the state of ls. So I don't pass anything for self. I only need to pass two parameters. You could imagine ls already has a self by calling ls.move, and I only pass those two parameters. And then I add the 2 to ls.x, and I add the -3 to ls.y by calling that function. And to see what happened, I call that ls print position just to print the x and the y. Whenever you write classes, it's good to have such dummy functions that print the present state of the function. It's very good for debugging and going through your code, understanding what your code does. So let's execute this very short snippet, and we would expect that it prints ls's position, which should be x of 7, 5 plus 2, and a y of 2, 5 minus 3, and that is exactly what happened. So we have defined our class. This class has two functions. By using that self object or self variable, I can assign all these variables that each instance of my class should have x and y. And this is a very basic definition of a class. And it's not a very good definition, because this self.x and self.y only appears somewhere in the code, but not at the beginning. And I'm able to instantiate a robot without giving it a position. So what would be better is that when I create my robot here, then I want to give it an initial position. And this can be done. And how is it done? It's done by the function called init with 2 underscores before and 2 underscores after. So this is a special function, and this very special function with exactly this name is always called when I create an instance of the class. So this function name is nothing that I can choose, that's defined by Python. So when I use this function name, then this function is called when I create a new variable of this class type. And I can define what shall happen after this init. So in our case, I want to give it an x and a y coordinate, and I want to assign that to the state of this, this object. So what I want to do is that self.x shall be whatever I pass here as an x, and the self.y shall be whatever I pass as a y. And the rest of the function remains the same as we had above. It can move and it can print. But the main difference is now I instantiate a robot, ls, and I give it the position. So I say x, your x is 5 and your y is also 5. And then I do the same with Bob, another robot. And I say, yes, your x is 0 and your y is 0. And I print just ls's position to demonstrate that this works. So the main difference is really happening here, where in contrast to before, I pass initial parameters for my state. And that's something that you should always do. So write your init function and give default values for those parameters so that your object is always properly defined with some default values. And let's run this code. The output is not so exciting, but it obviously works. So by calling ls is a robot with 5, 5, then ls's position is 5, 5. And then you could do some, more or less funny things that shall just demonstrate that you have now 2 objects and you can do something with them. So I could move Bob, and I want to move Bob a little towards ls, not fully, just half the distance between ls and Bob. And I want to move Bob towards ls, and then I want also to move Alice either away, and because of this initial position, it's straight away, and print both of their positions. So I could do that. So first Alice's position is 5, 5, and Bob's position is 0, 0. Then Bob moves half the distance towards Alice, and Alice after that also moves by 1 step. So Bob is now 2.5 and 2.5, but after that Alice also moved by 1 away from Bob. You could call it again to iterate through that. So now Bob would move half the distance between 2.5 and 6. And Alice would also go her step further away and is now at 7. And you can iterate that and see where it happens. Or you could play what happens if Alice moves in the other direction. Would they actually meet at some point? Or would they overshoot? This is just an example that you have two objects who both operate in this world, and you might have many more objects, and they can interact. This is basically it about object-oriented programming. It's quite unlikely that you need to write your own class when you do some analysis in science. It might be very helpful in a bigger project. But it will be necessary to understand, and you've already come across that, for example, when you used your NumPy functions, NumPy is not a class, but it is a package. But you have NumPy random.rand that you had, and so NumPy has an object called random, and that in turn has functions. So the behavior is a bit similar, like of a class, and that's symbolized with the dot here. And when you create deep neural networks, then you will have functions in TensorFlow, a powerful package that does all the work for you. But underlying is actually object-oriented programming, because a deep neural network, you will have one instance of a deep neural network, and one network consists of several layers, and layers, they have units, and then there are obviously some functions to train your neural network. So that's all object-oriented programming. You have your classes. It's at the beginning not necessary to dig deeper into that, but once you get more into that and want you to change your network slightly, if you want to define your own fancy activation function or so, then you could derive a class from an already existing class. So for the moment, it's just important to be aware that you can write your own classes, and that you now know what this dot is all the time. It's meaning just it's belonging to an object. So this was part 5 about classes.